Do you know how the electricity generated by power plants is transmitted to our users? We all know that the electricity generated by the power plant's generator is first boosted by transformers for long-distance transmission. Then at the destination the voltage is reduced. For users to use, these transformers used in the power transmission system are called power transformers. In practical applications based on the characteristics of transformers transforming voltage, transforming current and impedance, different types of voltage current and impedance transformation are produced to meet the needs of production and measurement. Today we will learn about the applications of some common transformers. First, power transformers. Power transformers mainly have two functions. First, the voltage at the generator's outlet is generally not high, so it cannot transmit electricity to distant places. Using the function of power transformers to raise the 550 kV generator's output voltage to 110, which can reduce line losses to achieve the purpose of transmitting electricity to distant places. The second function of power transformer is to transform the high voltage to low voltage distribution values. Because the voltage of the AC used in daily life is 220 volts, the line voltage of three-phase motors is 380 volts. This requires transformers to reduce the high voltage AC to 380 and 220 volts. Therefore, power transformers are key equipment in the power system. Second, self-coupled autotransformer. This is a self-coupled transformer, as can be seen from its schematic diagram. The primary and secondary windings of this transformer share winding. One contact of the secondary winding is often made into a free sliding contact, which can smoothly adjust the secondary voltage. The voltage regulator commonly used in the lab is a self-coupled transformer that can change the number of turns. 3-instrument transformer or voltage transformer. This is a voltage transformer. There are two sets of coils inside. The one with more turns is called high voltage winding, and the few turns are called low voltage winding. It is used in high voltage power supply lines. When used, the high voltage winding is connected across the circuit, and the low voltage winding is connected to the voltmeter. The indication of the voltmeter multiplied by the voltage ratio is the value of the measured voltage. When using a voltage transformer, we should pay attention to 2 points. First, voltage transformer as secondary side and the iron shell need to be grounded to prevent the insulation damage of high and low voltage coils, endangering the safety of the operator. Second, the low voltage coil of the voltage transformer cannot be short-circuited. If short-circuited, the low voltage coil will have a large current, which will damage the equipment. Next, let's look at the current transformer. This is a current transformer. Its primary winding has fewer turns and is wound with thick wires. The secondary winding has more turns, and the wire is very thin. When used, the primary is connected in series in the circuit. The secondary and emitter form a closed loop. The load current on the second side is equal to the reading of the emitter multiplied by the ratio of turns. When using a current transformer, we should pay attention to the following points. The secondary side and the iron shell must be grounded. Second, when the current transformer is working, the secondary side must not be open because current transformer is equivalent to a step up. transformer if it is open. A relatively high voltage will be generated, causing electric shock accidents. In this lecture, we have learned about 3 types of transformers: power transformers and self-coupled transformers, and the function and characteristics of instrument transformers. I hope that through this lecture, you can have a deeper understanding of the application of transformers. That's all for today's class.